Okay, in this video I'm going to continue on with exercise 6C of the book Fundamental Applied Mathematics, 164, or page 164, and the question is 4. Alright, so basically this question reads, free objects near the surface of Pluto have an acceleration of 4.44 meters per second squared. The mass of Pluto is approximately 6 times 10 to the 23 kilograms. Taking the gravitational constant as whatever it usually is, find the radius of Pluto. So let's go ahead and do that. This is pretty straightforward stuff. So we'll read it again now. It says its acceleration is 4.4. So we know that F is equal to ma, and we're talking about a mass. Now the question is this m, which one is it? Is it the big one or the small one? And how about if I said, what if I did the following? If I said it's the mass of body I'm going to call y. Well then, it's the mass of Pluto here and the mass of the body y here. Okay, so of course what we can cancel is the mass of the body y. So we can say A is equal to g times the mass of Pluto times the radius. Now what's the radius? It says that the surface is the distance between the two bodies is as follows. If you draw this as Pluto, where this is the radius of Pluto, and you're on the top of Pluto, the distance between the body and the center of Pluto is just going to be the radius of Pluto. Alright? It would be different, however, if you're asking what's the difference, the acceleration due to gravity, if it was like this. Then the distance between the two of them would be the radius of Pluto, the distance between here and here, and also the distance between here and here, the radius of the other body. But that isn't the case here. So let's just plug in our figures. We know it's 4.44 here. We know that the gravitational constant is 6.67 times 10 to the minus 11. We know the mass of Pluto. We're given it 6 times 10 to the 23 kilograms. We need to divide that by the radius squared, not just the radius, excuse me. So the radius squared is the radius of Pluto. And that's what we're being asked to find, so I'll leave it like that. So we can say that R is equal to the square root of 6.67 times 10 to the minus 11 times 6 times 10 to the 23 divided by 4.44, and like I said, all square rooted. So let's just plug that into the calculator. I know I made a bit of a mess up here, but I'm not going to change that. So 6.67 times 10 to the minus 11 multiplied by 6 times 10 to the 23 divided by 4.44, and square root that answer. And you get an answer of 3002251. Like I said before, that means it's 3.123456, 3 times, or let's say 3.0025 times 10 to the 12346 meters. So it's basically 3 million meters, and we know the radius of the Earth is, 8 million meters, I think it is. The radius of the Earth is 6 million meters, so it's half the size of the Earth. So let's just check this at the back of the book. 6C question 4, 3 times 10 to the 6. That's correct. So, thanks for watching. Please pass it on to your friends and subscribe to my channel.